Hello and welcome to our discussion of Python best practices. Originally, I was going to talk about Python error handling and logging. And then it occurred to me there's a broader topic here to talk about. So that's what we'll be talking about during this conversation. So jumping straight into our agenda, we'll go over error handling and logging. We'll talk about separation of concerns and then acronyms to live by. So starting off with error handling and logging. So what's the point? That's always a fair question to ask. And the basic idea here is that errors are most likely going to occur. It's a question of what should occur when they do happen. So you don't typically want a unhandled runtime error to cause your program to terminate. That is highly undesirable. Instead, you want to respond to it appropriately based upon the type of error that is occurring. And you also want to try to prevent or avoid undesirable situations such as partially processing something, leaving things in a state where you don't quite know how far maybe your processing got, and so on. So you want some degree of kind of assurance that things finished. If they didn't finish, you need to know why and how to resolve it. And that's basically it. You need to know if something happens, know that it happened rather than just blindly assuming things went well and having no insight whenever things don't. So to do that, there's several ways we can do it. We'll first talk about assertions. We've talked about them in the past. An assertion is something that you basically specify that is a precondition. It's what you expect to be true. You assert that some value is true. So as the example on the screen, it's asserting that there's some things in our list that we're going to try to take the average of. If there's nothing in the list, then what is the average of nothing? It's kind of undefined is the basic idea here. So you might could argue, well, the average of nothing is zero. That's not probably technically true. So to avoid a divide by zero, which is what would happen here if you didn't do this, you assert that there's at least one thing in that list of things that you're about to take the average of. Pretty good use of the type of assertion. It's also important that you don't catch the exception that's generated when an assertion occurs. As a general rule. As with all things, there are typically exceptions, but as a general rule, don't catch that exception that's generated, because the whole point of this is you're asserting something to be true, and it's something that is unimaginable that it's something else. That's basically the idea, is that you don't know what to do if this isn't true. That's basically the view of an assertion. So you definitely use it to specify some expected precondition of what it is that you're expecting things to be. As a general rule, you may want to apply this to all of your parameters that don't have default values to ensure that you don't have null values if you're expecting some value. So if you have a function that you've defined and you assume that there's going to be a value for each of the parameters and you don't supply a default value to handle that case of what should you do if they don't give you one, then you should probably be doing an assertion around those values. Those are kind of a general concept related to the use of assertion. Value substitution is another approach that you might utilize to avoid runtime errors. This is something that I would have made this in a bigger font and probably should have, and maybe blinking, right? Be careful, right? Because it's not something that you casually should do. The basic idea of value a substitution is that you have say a data set, and within that data set, you've got mostly good data for all of your records, but maybe there's a few records that are missing just a few things. So maybe you have a 100 question questionnaire that you've administered. People respond from 1 to 5. And for whatever reason, you've got one questionnaire that they missed two answers. So 98 of the 100 questions are present. So what do you do with those two questions that are missing values? Because you have to be cautious of how you handle that from an analytics perspective. One approach is to do an average of the values that are present and use that instead. May or may not be appropriate. And whenever you do these sort of things, you want to make sure that what you're doing is statistically valid, that you're not doing something that is skewing results in some negative way. And also the idea of using value substitution diminishes greatly of trying to do that is a less of an idea with the more things that you're doing substitution for. If you have 1,000 values and you're having to do one substitution for those values, that's not that big of a deal. If you've got 10 values and you're doing substitution for 5 of them, probably a big deal. So the point of that whole conversation is that there are ways to avoid sort of error conditions and so on by making sure that your data has proper values in it of some sort. And one approach to doing that is value substitution, but you should do so with a great deal of caution because it could throw off your results. Whenever we talk about try and except, we're talking about basically try, catch, sort of error handling. The idea is that you try to do some block of code. If something bad happens, you end up down in an except. We've talked about this in the past as far as the language constructs go, but there's some basic kind of concepts and theories that need to go with that. And these are kind of a list of things that I pulled together as they occurred to me, pretty much off the top of my head. So there may be a little bit of duplication and overlap. But the first one is only catch an exception if you know what to do with it. Don't catch some sort of a criteria. So don't have an exception block that is going to pick up some exception if you don't know what to do if you were to catch it. If you can't resolve the issue or don't want to know what to do when it occurs, then maybe you don't catch it. That's kind of a fundamental concept. If you do catch it and you do something, maybe you can't do something with it for whatever reason, it's outside of the parameters that you can handle, then you should raise or rethrow it with the original exception associated with that newly created exception that you're raising. This is similar to an inner exception in a programming language like C# or C++, where you have an exception object that references to another exception that caused it to come to be. So it gives you some insight at a higher level of how it is that you got to where you are. You also typically want to catch a particular type of exception. Don't catch all exceptions because you probably don't know how to do whatever needs to be done for all possible cases. Also, generally speaking, you want to handle those exceptions closer to the cause rather than further away. The reason being, the closer you are to the cause of an exception, the higher the chances that you can do something about it. So maybe you can fix it, maybe you can make it recover. So that's the other sort of guideline here is get as close to it as you can so that you can actually do something, but far enough away from it so that you have the context in which to work. So it's kind of a trade-off, but you don't want to just have it at the highest level where you catch it, because at that point, what are you going to do to recover? Probably not much. Generally speaking, you want to log exceptions as you encounter them so that you can look into why they're occurring and perhaps remove them. You might do that log locally using a error logging construct we'll talk about in a moment, or you might do it in some sort of a system that catches it over some sort of call to the cloud or whatever it might be. But you did, generally speaking, do want to catch them, because if you don't know about them, how can you fix them? And maybe there's systemic issues that are in your code that need to be addressed. So knowing that what is going on, the nature of those exceptions you're seeing, the types of them, maybe doing some analysis of your exceptions and so on can improve the quality of your code. Generally speaking, if you're doing something in the cloud, you're going to be trying to handle intermittent failures. So not everything works all the time in the cloud is the basic takeaway. Occasionally things are unavailable for whatever reason, and the right approach is to try again. But when you do that try again, make sure you're doing a delay, and more precisely a random delay between each of the tries. And also typically you'll want to include a maximum number of tries that you're going to use. This is to ensure that you don't turn your attempt at recovery into basically a stress test, right? So the random duration of the delay is to ensure that if the thing that caused you grief also is delaying, that you don't bump into it again. It decreases the odds of that. Avoid displaying or logging a call stack. And the reason being, if you make that available for consumption, then somebody may know about your code, and it could be a security vulnerability. This may be less of an issue under a lot of circumstances, but it's something to keep in mind and to think about is, should I be writing this out? And especially if that's something might include passwords and usernames, probably not a good thing to put in a log file. Avoid empty except blocks. And what that means is don't catch something that is an exception and then do nothing. So in Python, there's this pass keyword that basically is a no-op. It doesn't do anything, but it makes it so that it's there and you don't get some sort of a syntax error saying there's an empty block. But you wouldn't want to do a try with some stuff and then an accept and pass. Sure, you're not going to get any runtime exceptions, because, well, you will. You just won't see them because they're going to go there and you're going to ignore them. That means you'll never be able to correct them. And probably it's not going to be all that reliable because you don't know what's succeeding and what's failing. Moving on to error logging. Only log information that's necessary to diagnose and reproduce a problem. So that's the whole point of this, is to capture something so you can tell what's going on. That's where this concept of verbosity will come to play, which is what you're seeing right here. This is a logging library that's built in basically, or it's accessible typically without a whole lot of work. Maybe it's built in, I don't know, but it was there without me having to do any kind of import or any kind of installation. And what you can do with that is basically import it so it's available for your usage, then configure it to, say, in this case, write to a file with the OSO original name of test.log. And you set the verbosity, which is how much of what type of things, basically, what type of things are going to be logged. So in this case, I'm saying it has to be at least an error to be logged. Error and critical are the two things that will be logged. Critical is more important than error. So if you take a look at the code, I'm making a call to log.critical, doing some string substitution here where it's taking this parameter and shoving it in here. Not all that meaningful in this case, but if this were a variable, pretty useful. You don't have to do string concatenation, kind of printing it out for you. Log.error, that's those two things are actually getting written out because it's critical and error. The warning, info, and debug aren't getting written out because we're set to logging.error for our levels. So what that means is we're saying we don't care about things unless they're really important. They're either errors or critical. Uh, Taking another look at that a little more detail, logging revisited, as I said, is take a look at this. This is the logging library that I'm utilizing. You can specify a format so that the lines that go into your file are of a certain type, including some things that are kind of predefined. This URL talks about that, so you may want to pause and go take a look there. You do something similar with a basic config. I tell it the format, and I give it that format string, file name. In this case, I'm calling it verbose.log, almost as original as the first file name. And then I set the level to not set. What that means is I want everything. And then I go through and do the similar things of I'm do a critical, an error, a warning, an info, and a debug. And you notice over here, they all get written out because we're set to not set. If we were to have set at one of these in like a warning, we would see warning, error, and critical, but not info and debug. So it's in this order. And again, this documentation tells you that. The logging.shutdown, you'd want to be cautious if you're using it inside of Jupyter Notebooks or something, because it's intended to basically be in a Python program and it's the last thing you do. The reason I'm calling it is because I wanted to flush these files out. And that's the way logging typically works. There's buffers involved so that when you log, it doesn't necessarily go straight to the file. It does it in chunks whenever it has time, whenever there's enough stuff to write, and so on. By doing logging.shutdown, I'm basically saying I'm done, close the files. And that's the whole point of this, so I could grab those files. Moving on to separation of concerns. So what's the point? Your basic idea whenever you're building or writing code is to have things together that make sense to be together, and they do, generally speaking, one thing. And they do it well. And that's kind of the intent of this sort of talking point, is to make sure that you have your code, be it a file, a class, or whatever it might be. Make sure that things that are there go together and they do one sort of set of operations that make a lot of sense to be together. And part of the reason you do that is that you don't want something that's a ripple effect to occur. You don't want changes in one area to impact another one. And if you have them physically separated into potentially separate files, that's less likely to occur. That's where I've used this concept of clustering things together that makes sense. So you want your code, methods, and the data that it goes with them kind of all to be together, ideally in classes. So that's kind of the whole point of defining classes that we've talked about in the past. And as a general rule, though, don't have one class that does everything, and that's a kitchen sink class because it does everything and the kitchen sink, right? Or except the kitchen sink. So basic idea here, though, is that your classes should be lean. They should do what's necessary and no more. And that's always a challenge because we all have tendencies to put stuff in there in case we need it. We'll talk about that in a moment. As a general rule, don't do that. Make it as simple as possible and as concise as possible, and have things together that make sense to go together. These things, concepts, relate to this concept of cohesion and coupling. Those are object-oriented concepts, kind of a bit beyond the scope of what we're talking about right now. But the basic idea here is that you want things to be that go together, to fit together, and to be relatively small and well-defined and have a purpose together. And generally speaking, you want to minimize the amount of coupling that's going on so that there's not a lot of dependencies between elements. There shouldn't be a lot of function calls between unless it's absolutely necessary. The last conversation here is don't copy and paste code, because that's almost a bad idea. Doesn't exactly fit here, but instead of copying and pasting, you want to take the concepts you're doing, abstract it, separate things out, and do it reuse that way rather than copy paste. And copy paste is bad, and we'll talk about that in a moment. I borrowed from a chapter in a book about acronyms to live by. The basic idea here, these are some concepts. Don't memorize the acronyms, nobody cares, but these are concepts that you typically want to allow to manipulate or influence what you do. So moving on to the first one of these is don't repeat yourself, and once and only once. And those two things are kind of related to the concept of avoid duplication. This is all about copy paste or functions that maybe you didn't actually go to the trouble of copying and pasting. Maybe you wrote them twice, or maybe you've got two different people wrote something that does the same basic thing. The basic idea though is you have one thing that does it and does it well. Again, back to that concept. The reason you don't want duplications and you don't want copies is, first of all, it's error prone. Anytime you make a correction, you got to make that same correction n times, where n is the number of copies that have been made. That also influences potentially the expense of maintaining that code. Maintenance costs go much higher if there's duplicate versions of code, and because there's also this concept of potentially diversion, so that the code bases diverge over time, so that two functions started off being copies of each other. Somebody made some changes to one, hijacked it because it's in a different call stack or whatever it might be, and then they look very similar, but they're actually different. And because of that, you end up with things being unreliable, potentially prone to error, because they're not generally well documented, and there's the it's difficult for an issue to be whenever maintenance is being done by multiple people. So if you have a single person and it's just your code, and you're the only ones that are going to maintain it, you may not worry about some of these things. If you work with a team, or maybe you switch jobs, it becomes more of an issue for whoever comes after you. So try to be nice to them, and who knows, it may be you, because you may make some changes to some code or write some code, put it on a shelf where, or maybe it's being used for several years. You come back to it and have to look at your own code, and before you start getting critical of whoever wrote this crappy code, you find out you're the one that wrote that crappy code. So be kind to yourself and to others. Avoid things like duplication. You ain't going to need it, and that's the Yagni approach. And that basic idea here is don't over engineer. If in doubt, keep it as simple as possible, and only build something that you know that you're going to need. We all have tendencies to really build cool stuff, so you want to avoid that. The simplest solution is going to work, and that's where this keep it simple concept comes to play. Occam knew what he was talking about. If all things are basically equivalent, and the simpler solution is going to be the better one. That's the basic sort of concept. The corollary, if you're Occam's professor, you make the student do it as in the most complex way possible. But that's more humor than reality, although there's some truth to that for a lot of cases. So these last 2 points kind of deal with the concept of philosophy and Pythonic sort of patterns. And by Pythonic, we talk about it. We mean things that relate to how Python code should typically be written by those that write Python code. A little bit of snobbery, but that's okay because they write a lot of Python code. The basic idea here is there's two approaches to dealing with problems. One is avoid all possible problems by inspecting all the values before you do anything. And that's the look before you leap approach. That's the way that you typically do things in a lot of traditional programming languages like C++ and so on, and C sharp. And the reason we do that is because we've got compilers in the mix, and we can do a whole lot of checking in a cheap way. When you're dealing with something like Python, you're dealing with interpreted code that's a little more expensive to do all that error checking. So rather assume that it's going to work. And that's where it's easier to ask for permission, easier to ask for forgiveness and permission approach comes to play. So in that scenario, you assume that everything is going to work out, and you handle the things that don't. So basically, you're going to have a fair amount of code and some try blocks and some except blocks that catch it whenever things go badly in very specific sort of targeted ways. And from a Pythonic sort of approach, it's the more appropriate way to go. So consider that whenever you're writing your code. Either approach potentially is valid, but make sure that it's an informed and conscious decision that you're doing. Here's a couple of resources that I utilized during the preparation of this material. Pretty good stuff. Also, there's a book that's like a Python cookbook, also a very good resource as well. As always, if you have any questions, reach out to me. That's what I'm here for. Stay safe, and we'll talk again later.